Welcome to BMSC Phase Shift 2015. This is electrical department and this is a place allotted for us. The first project what we are going to talk about is a bifurcated winding induction generator. Yeah. And this is a new configuration of induction generator which has 6 inputs and 6 outputs. Wherein it has a standalone capability, it is a voltage, it can be controlled, and then it produces a constant output frequency and constant output voltage.
The next project what we are going to talk about is UPQC, Unified Power Quality Conditioner. It is used for removing the harmonics, and it is a total solution for the harmonics. So the whole thing takes care of about voltage and current waveforms. So it makes it purely sinusoidal.
Next we have the balloon set. It consists basically of a balloon and a payload system. This is the payload system with sensors and Arduino controller. It senses the voltage, pressure and temperature in the atmosphere and gives us valuable information. The next project.
Hologram. Hologram is it is just device like which projects the 3D projections of an object. Now here we have a setup where we have a glass pyramid, and we have a display system, and this display system has 4 parts, like 4 video parts, which one of the video is the front view of an object, back view of an object, left and right profile of an object. It's being projected on the 4 surfaces of the glass pyramid, and ask Akshit to talk about.
Okay, so which is visible. This is the torus from where the electrical discharge takes place, and this side is the primary windings. So what actually is happening is, if you keep anything around this Tesla coil which is operating at more than 7.5 kilovolts, so the output here of the voltage is more than 1000 volts. So what happens is, you can see an electrical discharge across the air. So if I keep anything which is conducting near to it, immediately you'll see a spark lighting going through the air. So this is it about it. Now regarding the haptic arm, Nikhil will tell regarding the haptic arm.
Here we hello guys, I am Nikhil. I am from EEE department. Here we are going to explain about the robotic arm. We have developed a robotic arm with a human interactive robotic arm. What we are doing is, we are using the image processing technique. Like we are wearing color bands in each of the fingers, and we are placing a overhead camera. When the camera recognizes the color, the video is sent to the computer that recognizes the color. When there is a motion in the color, that is the XYZ coordinate, when it varies, the variation will be sent to the controllers. That controller will set the pulse to the servo motors which are fixed to the robotic arm. That servo motor, when it runs, it pulls the thread, and similarly the finger moves. For the finger, we have given the 3 degrees of freedom. As you can see, the first degree of freedom is here, second, and here the third degree. So for each finger, we have given a 3 degree of freedom, similarly like the hand, the first degree, second degree, and the third degree of freedom. Thank you. Yes, Satya will explain about the load management.
This is basically a smart grid, part of a smart grid. This is basically part of smart grid. Smart grid comprises of 2 parts, like power quality and load management. This is load management. Load management means just managing the loads, and here for load management comprises of 2 parts. Power calculation and load identification. For power calculation, I am using C2000, and for load identification we are using MSP430, and above MSP430 there is TRF7970 booster pack, which has an NFC reader which reads the data present in this NFC. This NFC will be placed behind every socket, and from that we get the load information, and we use current sensors and voltage sensor to measure the power, and this will be calculated by DSP microcontroller C2000, and the load values sent by MSP430 will be processed by C2000, and it will be sent via Ethernet, and you will get on your and you will get the UIDs and the power values for every 20 milliseconds in Ethernet, and you can see the power values. 1 minute. and you can see the power values of these two loads. Like voltage is around 220 volts, and output of this bulb is like 100 watts mentioned. We are getting like 98 watts, and output of this bulb is 60 watts, and here we are getting like 55 watts. And as both of these are resistive loads, uh, it should be unity power factor, so we are getting as 0.98 power factor. And the load identification details is can be obtained on a software called Docklet, in which the data present in this is displayed in ASCII format. You need to decode this to get the actual data present in the NFC tags. Thank you.